Hello everyone, once again welcome to my YouTube channel Physics with Dr. Sanjay Bhargava. In this video of microwave electronics, we'll continue our discussion on conductor attenuation in rectangular waveguides due to the wall currents with TE and TM modes. In the earlier video, we had already discussed about the two different ways of attenuation in a waveguide. The third method is attenuation due to conductor losses. Loss in the waveguide walls. The time average power transmitted through the guide walls is given by this relation: power transmitted is equal to 1 upon 2 Z0 E transverse का whole square ds और is equal to Z0 by 2 HT का whole square ds. Due to finite conductivity, the tangential component of the magnetic field and the normal component of the electric field is not zero. HT and En modify the field configurations and HT causes the surface current to flow. HT causes surface current to flow, which becomes the main cause of power loss. तो finite conductivity के कारण क्या होता है? Finite conductivity के कारण इलेक्ट्रिक फील्ड का टेंजेंट नॉर्मल कंपोनेंट और मैग्नेटिक फील्ड का टेंजेंशियल कंपोनेंट जीरो नहीं हो पाते हैं, जबकि बाउंड्री कंडीशंस के अनुसार इन्हें जीरो होना चाहिए था, और ये दोनों ही मेन कॉज ऑफ पावर लॉस बन जाते हैं. HT and En, small t represents the tangential component, n represents the normal component, result in average power delivered to the walls and is lost in it. तो ये क्या करते हैं? ये दोनों कंपोनेंट के कारण जो वेवगाइड की वॉल्स हैं उनको कुछ पावर ट्रांसमिट हो जाती है, जिसके कारण पावर लॉस हमें देखने को मिलता है. दिस प्रोड्यूसेस continuous attenuation of propagating electromagnetic waves. When the electric and magnetic intensities propagate through a lossy waveguide, then their magnitudes are given as E is equal to Ez0 e power minus alpha z. Ez0 the maximum amplitude of the electric field, Hz0 the maximum amplitude of the magnetic field, alpha that is the attenuation constant, and z is the direction of propagation, where Ez0 and Hz0 are the field intensities at z is equal to 0. The average power transmitted through the guide walls would be given by Z0 by 2 HT ka square e power minus 2 alpha z ds. HT represents the transverse component of magnetic field. The integration over the surface shows integration over cross section of the guide. For a low loss guide, the time average power flows decreases proportional to e power minus 2 alpha z. अगर मान लीजिए we have a low loss guide, तो उस केस के अंदर the time average power flow would decrease proportionally to e power minus 2 alpha z. The power lost per unit length of the waveguide is given by the rate of decrease of power transmitted. So power lost per unit length is given by minus delta pt by delta z, which would be equal to alpha z0 integration over the cross section ht ka square e power minus 2 alpha z ds. Dividing equation number 2 by 1, what we obtain? Attenuation constant alpha would be equal to pl upon 2 pt. So from equation number 3, we are in a position to define attenuation constant. Thus, attenuation constant alpha is the ratio of power lost per unit length to twice the power transmitted in the guide. So this gives us the basic definition of attenuation constant, which is equal to the ratio of power lost per unit length upon twice the power transmitted in the guide. The electric and magnetic intensity established at the surface of a low loss guide would decay exponentially with respect to the skin depth while the waves progress into the walls. जब waves वेवगाइड की वॉल्स के अंदर प्रोग्रेस करते हैं तो वहां पर जो फील्ड्स हैं दे डीके एक्सपोनेंशियली with respect to the skin depth. What is skin depth? Basically the depth up to which the fields penetrate the thickness of waveguide walls. The surface resistance of the guide walls RS is equal to 1 upon sigma delta, which is equal to under root omega mu upon 2 sigma. What are the different letters indicating here? Mu represents magnetic permeability. Sigma, it represents the conductivity of metal at angle of frequency omega, where delta is supposed to be the skin depth measured in meter. The power loss per unit length of the guide is obtained by integrating the power density over the surface of conductor corresponding to unit length. So power loss is given by Rs by 2 integration ht ka square ds, where ht is the tangential component of magnetic field. Alpha is basically given by PL upon twice PT. अभी determine किया था हमने. So the ratio gives me Rs upon twice Z0 integration over surface S1 ht ka square ds1 integration S ht ka square ds. Ht is the tangential component and capital T represents the transverse component. How do we calculate the transverse component? So here we have the transverse component magnitude ka square would be equal to magnitude of hz ka square plus magnitude of hy ka square. Similarly, the tangential component ht ka square would be equal to htx ka square plus hty ka square. S1 is the metal surface and S is the waveguide cross section. The numerator is calculated at each conductor, while in denominator it is over the cross section of the waveguide. So S represents the entire cross section of the waveguide while S1 represents a single surface. Now we would like to calculate conductor attenuation in a rectangular waveguide. For the first part we will pick the TMN mode. The TMN modes in the rectangular waveguide are Hx is equal to j omega epsilon a ky upon h square, sine of kxx cos kyy e power minus gamma z. Similarly, hy would be given by minus j omega epsilon a kx upon h square cos kxx sine of ky into y e power minus gamma z. For TM modes, hz is supposed to be 0. These modes already have been calculated by us in the video on waveguides. Similarly, Ex would be equal to minus gamma a kx upon h square cos of kxx sine of kyy e power minus gamma z. Ey is equal to minus gamma a ky h square sine of kxx cos of kyy e power minus gamma z. Similarly, Ez would be equal to a sine kxx sine of kyy e power minus gamma z. These represents the TM modes in the rectangular waveguide. The upper and the lower walls are in the xz plane. The upper and the lower walls are supposed to be in the xz plane. So tangential components are hx and hz, and here hz is supposed to be 0. The power loss per unit length in the lower and upper walls is given by PL1. It gives me power lost in upper and lower walls. So there are one upper wall and the other is the lower wall, both lying in the xz plane. So finally we have a multiplication by the factor 2 because there are two walls, the lower and the upper, into Rs by 2 surface integration ht ka square ds, that would be equal to Rs hx ka square y is equal to 0 and y is equal to b dx. Hx is the maximum value at y is equal to 0 and y is equal to b. Here cos ky into y would be equal to 1. So we need maximum value of hx. So just see, hx is here. So when hx is here, cos y का value एक बार हम 0 रख सकते हैं, तो cos 0 would be 1. So for maximum value of hx, cos ky, this factor, that is cos ky, has to be 1. That is what we have shown here. Cos ky would be equal to 1. Now PL1 therefore would be given by Rs omega square epsilon square a square ky ka square h power 4 0 to a, because x varies from 0 to a and y varies from 0 to b, sin square kx x dx. So what would be the integration here? It would be equal to a by 2. So that is what is a by 2. Similarly, I can calculate power lost per unit length in the side walls. So in the side walls, this would be, again, there are the two side walls, so I multiply by the factor 2. Rs by 2, 0 to y, hy ka square at x is equal to 0 and x is equal to a dy. Hy is supposed to be maximum at x is equal to 0 and x is equal to a. So cos kxx has to be equal to 1. So for maximum value of hy, we need to keep cos kxx as 1. So what do we get? PL2. PL2 would be equal to Rs omega square epsilon square a square kx ka square h power 4. Integration extending from 0 to b, sin square kyy dy, and this entire integration would be equal to b by 2. So I have b by 2 here. The total power lost per unit length would be equal to PL1 plus PL2. So PL can be written as Rs omega square epsilon square a square 2h power 4 ky ka square a plus kx ka square b. What is the value of kx? Kx is m pi by a. Ky is n pi by b. So substitute here. What will I get? Rs omega ka square epsilon ka square a square pi square 2h power 4 n square a upon b square plus m square b upon a square. The power now we have the total power lost. We need to calculate the power transmitted. Then we can calculate the attenuation constant. The power transmitted through the waveguide is given by Z0 by 2 closed surface integration ht ka square ds or ZTM by 2 integration hx ka square plus hy ka square dx dy. Now substitute the value of hx and hy. Integration for x extend from 0 to a and for y it extends from 0 to b. Omega square epsilon square a square ky square upon h power 4 sin square kxx cos square kyy dx dy. Similarly, integration extending from 0 to a, 0 to b, omega square epsilon square a square kx ka square h power 4 cos square kxx sin square kyy dy dx. Now just simplify. Break them first into individual integrations. So ZTM by 2 ओमेगा स्क्वायर को कॉमन ले सकते हैं, एप्सिलॉन स्क्वायर को कॉमन ले सकते हैं, ए स्क्वायर को कॉमन ले सकते हैं, h पावर 4 को. यहाँ पर हमारे पास बचेगा ky का स्क्वायर इंटीग्रेशन 0 टू a sin स्क्वायर kx x dx. सिमिलरली 0 टू b cos स्क्वायर ky y into dy, kx का स्क्वायर cos स्क्वायर kx into x dx. इंटीग्रेशन 0 से b sin स्क्वायर ky into y. Now all these integrations would be limit upon 2. So this is a by 2, this is b by 2. This is once again a by 2 and this is once again b by 2. So here we have a by 2, b by 2, a by 2 and b by 2. Just try to simplify. Now ZTM by 8 omega square epsilon square a square ab h up power 4 bracket में आपके पास बचेगा ky का स्क्वायर अपॉन kx का स्क्वायर, राइट. एंड व्हाट इज ky का स्क्वायर एंड kx का स्क्वायर, वो हमें मालूम है. तो दिस कैन बी रिटन ZTM ओमेगा स्क्वायर a स्क्वायर ab अपॉन 8h स्क्वायर. ZTM would be equal to eta integration 1 minus fc by f का स्क्वायर और in terms of wavelength eta 1 minus lambda by lambda c का whole square. So power transmitted must be equal to eta omega square epsilon का स्क्वायर a स्क्वायर अंडर रूट ऑफ 1 माइनस lambda by lambda c का होल स्क्वायर a into b अपॉन 8h स्क्वायर. नाउ नीड टू कैलकुलेट अल्फा. अल्फा हमने डिफाइन किया था, इट इज इक्वल टू द रेशियो pl अपॉन ट्वाइस pt. So we have already calculated PL, we have now calculated PT, so just calculate the ratio by substituting the various quantities. So PL upon 2 PT, which can be written as r square omega square epsilon square a square pi square upon 2 into 2h power 4. Substituting the various quantities, kx square को substitute किया, ky square को substitute किया, 8h square eta omega square epsilon square a square under root of 1 minus lambda by lambda c का whole square ab, that is power transmitted. On simplification, we obtain 2rs pi square n square a upon b square plus m square b upon a square, and in the denominator we have a b h square eta under root of 1 minus lambda by lambda c का whole square. H square can always be written as omega c का square mu epsilon. So h square, it can be written as omega c का square mu epsilon, and h square can be written as 4 pi square upon lambda c का square. So alpha can be written as rs का square lambda c का square ab upon 2 eta n square a upon b square m square b upon a square under root of 1 minus lambda by lambda c का whole square. Just simplify. rs lambda c का whole square 2 eta ab, and just adjust the terms. So we get L value of alpha for TM modes. Similarly, the same type of analysis can be carried out for the TE modes. So for TE modes, alpha would be given by 2rs upon eta b under root of 1 minus lambda by lambda c का whole square, 1 plus b by a lambda by lambda c का square, plus 1 minus lambda by lambda c का whole square, b by a m square plus n square upon b square m square upon a square plus n square. So we can calculate this relation by doing similar type of analysis. But in the rectangular waveguide, the dominant mode is TE10 mode. So we like to calculate alpha for the dominant mode in case of a rectangular waveguide. Now TE10 is the dominant mode in rectangular waveguide. The field components are given as, the Hz is given as b cos pi x upon a e power minus gamma z, Ez is 0, Ex is 0, Hx would be given by gamma b h square pi upon a sine of pi x upon a e power minus guy. Hy is also 0 and Ey would be given here. So Ey is given as minus j omega mu upon h square pi by a b sine of pi x upon a e power minus gamma z. The power loss in the two side walls of the guide. So PL1 would be equal to 2 into Rs by 2 h tangential का square ds. So that would be equal to 2 into Rs by 2 hz का square at x is equal to 0 and x is equal to a dy. The two side walls are in the yz plane. Here Ez is supposed to be 0. So tangential component are hy and hz, but here hy is supposed to be 0. So we have hz only. So substitute the value of hz, we get PL1 would be equal to Rs b cos pi x upon a at x is equal to 0 and x is equal to whole square dy. That would be Rs into b square, integration 0 se b dy, and that would give me the answer Rs b square b. Upper and lower walls are in xz plane. So power loss per unit length in the upper and the lower walls, PL2 would be equal to 2 into Rs by 2. 0 to a hx का square plus hz का square at y is equal to 0 to y is equal to b dx. Substitute hx and hz. So 0 से a beta square b upon pi by a का whole square sin square pi x upon a dx. Similarly 0 to b square cos square pi x upon a dx. So this would be equal to beta square a square b square upon pi square. This would give me a by 2 plus b square, and this would give me a by 2. So I'll have Rs b square a by 2 into 1 plus beta square upon pi by a ka whole square. For TE10 mode, beta is given by omega square mu epsilon minus pi upon a ka whole square. So PL2 would be equal to Rs beta square a by 2 omega square mu epsilon upon pi by a ka whole square, and the total power loss would be equal to PL1 plus PL2. Just add the two quantities calculated by us. So PL would be equal to Rs into b square b plus into 1 plus a upon 2b omega square mu epsilon upon pi by a ka whole square. Remember omega c mu epsilon is pi by a ka whole square. So omega square mu epsilon upon omega c mu would be omega by omega c ka whole square, can be written as lambda c by lambda ka whole square. So that is why here we have lambda c by lambda ka whole square. Then now we need to calculate what would be the total power transmitted. हमें total power transmitted in the guide TE10 mode में calculate करना पड़ेगा. तो PT would be equal to Z0 by 2 integration over the entire surface HT ka square ds. This represents the transverse component, and transverse component would be the x component and the y component. So hx ka square plus hy ka square dx dy. So Z0 by 2, hy is 0, so integration hx ka square dx dy, Z0 by 2, 0 से a, 0 से b, b square beta square upon pi by a का whole square, sin square pi x dx dy. So integration 0 से a, and this sin square would give me a by 2, and integration of dy from 0 to b would give me b. So I have b here and a by 2 here, and remaining are the constants z0 by 2, beta b square beta square pi by a ka whole square. Now what is z0? Z0 is Z, T, E10 is eta upon under root of 1 minus Fc by F ka whole square. So this can be written as, beta can be written as omega square mu epsilon 1 minus omega c by omega ka whole square, can be written as 1 minus Fc by F ka whole square. So this, substituting the value of Z0 as eta upon 2 under root 1 minus Fc by F ka whole square, b square ab upon 2 pi by a ka whole square, and beta square as omega square mu epsilon 1 minus Fc by F ka whole square, which can be simplified eta a b square omega square mu epsilon 4 upon pi by a ka whole square under root 1 minus Fc by F ka whole square. So we have the equation for power transmission, eta ab b square upon 4 f by fc ka whole square under root 1 minus fc by f ka whole square. In terms of wavelength, it can be written as eta ab b square upon 4 lambda c by lambda under root of 1 minus lambda by lambda c ka whole square. So first part of the equation in terms of frequencies, the second part of the equation in terms of wavelength. Now to calculate the attenuation constant, we have to substitute power lost and power transmitted in this equation. The attenuation constant alpha is equal to PL upon twice PT. Substituting the values Rs b square b 1 plus a upon 2b lambda c by lambda ka whole square upon 2 eta a b square upon 4 lambda c by lambda ka whole square under root of 1 minus lambda by lambda c ka whole square. So alpha would be equal to Rs 1 plus 2a 2b upon a lambda by lambda c ka whole square eta b upon under root of 1 minus lambda by lambda c ka whole square. After further simplification, it can be written as Rs upon eta b 1 plus 2b upon a fc by f ka whole square under root of 1 minus fc by f ka whole square. So first part of the equation in terms of wavelength once again, and the second part of the equation in terms of frequency. So this gives me third part of attenuation, that is attenuation due to current in the walls of the waveguide. Then we calculated what would be the value of attenuation constant for TM mode and TE mode, and simultaneously we determine the value of alpha for the dominant mode TE10 in the rectangular waveguide. Hope this video would be useful for all of you. In case you find our video useful, please like it, comment over it, subscribe the channel and press the bell icon button so that you get notification timely for the new videos supposed to come in microwave electronics. Thank you all.